In this video, we'll talk about thermal expansion. Most materials expand when their temperatures increase. So for instance, liquids will expand in the thermometer. The metal lid on a jar can actually be loosened by running it under hot water because it expands more than the glass that it sits on. These are examples of thermal expansion. There are two types of thermal expansion that we're going to look at. We're going to look at linear expansion and volume expansion. Suppose a rod composed of some substance that has a length of L naught at an initial temperature of T naught is shown below. If the temperature is changed by delta T, the length will change by delta L. If delta T is not too large, then delta L is directly proportional to delta T. So here we have the original rod with some length L naught at some temperature T naught. We're going to change the temperature by a certain amount, which we'll call delta T, and that means that the length will expand by some amount delta L. Now again, this is only the case if the delta T is not too large. That means that the change in the length of the rod is going to have some proportionality constant. So delta L is going to be equal to alpha L naught times delta T. Alpha is the coefficient of linear expansion. So here are some values for the coefficient of linear expansion for different substances. Now keep in mind that you're going to multiply all these numbers by 10 to the minus 6, and you're going to divide it by degrees Celsius or Celsius degrees, and that's the unit, 1 over Celsius degrees. Let me tell you the difference between degrees Celsius and Celsius degrees if you didn't already know those. When you have degrees Celsius, that's a specific temperature. When you have Celsius degrees, then that tells you it's a change in temperature. If you look at the formula here, let's go back to the previous slide. This is going to be delta T. So in order for you to get a unitless quantity where L naught has the units of delta L, then the units of alpha must be the same as the change in temperature. Well, the change in temperature actually has the units of Celsius degrees, not degrees Celsius. So this is a little bit of a typo. This should actually be on the other side. So let's see if we can remove that and put that there. There we go. So it should be Celsius degrees. Okay, so if you look at all of these coefficients, ice has the largest, it's 51. Okay, aluminum is next with 23.1 times 10 to the minus 6. And then we also have copper, iron, steel. Notice that diamond, glass, they do not have very large coefficients of linear expansion. A steel rod measures 10 meters at 0 degrees Celsius. Given that the coefficient of linear expansion of steel is 1.2 times 10 to the minus 5 per Celsius degree, what will the rod measure at 75 degrees Celsius? Go ahead and pause the video now and solve this problem. Okay, so let's take a look at the solution. L is equal to L naught plus delta L. L naught times 1 plus alpha delta T. We're replacing the delta L here with alpha delta T. Okay, and that would give you your L naught. So we're going to pull out an L naught. We substitute in the numbers and we end up with 10.009 meters. Notice that we start with 10 meters and it increases by 9 millimeters. A simple pendulum is made of a steel string supporting a brass sphere. The temperature in a room with the pendulum is increased from 15 degrees Celsius to 30 degrees Celsius. Which of the following is true about the period of oscillations? Now, in order to solve this problem, you're going to have to think back to what you remember about simple harmonic motion in the AP Physics 1 curriculum. Okay, so let's look at the answer. C is the correct answer. The period will slightly increase. The absolute temperature increases from 288 Kelvin to 303 Kelvin. So L will increase slightly. That means that the period will increase slightly because the period is equal to 2 pi times the square root of L over G. Let's talk about volume expansion. Suppose a volume has some substance like gas, liquid, or solid. It has a volume of V naught at some initial temperature T naught. If the temperature is changed by delta T, the volume will also change by delta V. If delta T is not too large, then delta V will be directly proportional to delta T. So we can write that as delta V, which is the change in the volume, is equal to beta times V naught delta T, where beta is the coefficient of volume expansion. V naught is the original volume, delta T is the temperature change. Here are some substances where their volumes could expand. We have gasoline, glycerin, water, all the way down to gold, diamond, steel, glass. Notice that gasoline, glycerin, and water expand a lot more than you have for your solids. And again, just a reminder that this should be Celsius degrees and not degrees Celsius. Okay, a glass flask is filled to the brim with glycerin, both at the same initial temperature. When the temperature of the flask and the glycerin is increased by a few degrees, which of the following occurs? Now, they do give you the coefficients of volume expansion for the glycerin and the glass. Will A, the level of the glycerin in the flask go down? Will the level of the glycerin in the flask remain unchanged? Will the glycerin overflow? Or there isn't enough information to answer this question. If you need to pause the video, go ahead and do so now. Okay, so let's take a look. The answer is C. The glycerin has a much greater coefficient of volume expansion than the glass. Therefore, when the temperature rises, the glycerin will overflow the container. Let's talk about volume expansion of water. Water has a unique expansion property. When water is above 4 degrees Celsius, it expands when heated. Okay? But in the temperature range between 0 and 4 degrees Celsius, the volume decreases as the temperature increases. This means that at 4 degrees Celsius, the water is more dense than at 0 degrees Celsius. So water has its greatest density at 4 degrees Celsius. So if you have water at 4 degrees, it will actually sink to the bottom of the lake. And ice will form at 0 degrees, and that will cause it to float. This protects the life of the sea creatures in the water, since the water on the bottom will be at worst 4 degrees Celsius and not freezing. Okay, so this allows fish and other creatures to live in the water. Okay, so 4 degrees, it's the most dense. In the next video, we'll talk about heat and temperature change.